Hi everybody, I'm Bill Brennan, welcoming you to another edition of Honolulu on the Move, the show that brings you the latest news and information about the Honolulu Rail Transit Project. You know, one of the most exciting days for our project was when our first rail train cars arrived. That was back at the end of March. And today my guest is the man who oversees the fleet of train cars for our rail project and all the electronics that go with them. He's the Deputy Director of Core Systems for HART, and he is Justin Garrett. Justin, welcome to the show.
Thanks, Bill. Happy to be here.
Good. Tell us a little bit about yourself and your background and what brought you to the Honolulu Rail Project.
Okay. I've been in transit for about 18 years. I started as a maintenance manager for a FRA fleet of trains in Seattle, and then quickly moved after about 5 years over to Sound Transit. And I spent 12 years working on bringing light rail to Seattle. Our first line opened in 2009. For the first 5-6 years of that period, I was a vehicle project manager, managed the train delivery for the Seattle project. Then as I progressed in my career, I took on management roles as design leads for the University Link extensions. And then just prior to leaving Sound Transit, I was the director of all systems engineering, very similar to the role that I play here at HART. And you asked me what brought me to Honolulu. Well, I've always said that if I had an opportunity to come to Honolulu and work on the rail project out here, I'd jump at the opportunity. And I got a call one day that somebody thought I might be interested in a position to come out here. So here I am.
Well, welcome. We're happy to have you. What exactly is Core Systems? What does that mean? We use that word in-house all the time, Deputy Director of Core Systems. Right. And what is Core Systems?
Core Systems, basically as you described it, it's trains and all the power, signaling, and controls that we implement to manage the trains and the operations of the trains. So if I break it down into its parts, it's 20 trains. It's traction power substations, which takes HECO power in and converts it to DC voltage power that provides power to the trains. It's the signaling houses that we deploy throughout the systems that control the safe movement of trains throughout the system, ensuring that there's safe train separation and safe braking and keeps all the passengers moving where they need to go. It's all the communications, the fiber backbone network, and the controls that monitors the system. We've got thousands of points of devices out in the field that we're monitoring back at a control center, where we'll have a operations controller watching over train movements and also watching over the health of the system. And in a nutshell, that's basically what Core Systems is all about. It's a bunch of cable, fiber, and control systems.
Yes. And we advertise ourselves as the first fully automated driverless metro system in the United States. And what's unique about that? What's challenging professionally for you with that part of things?
Well, it's another layer of control and safety checks to make sure that the trains are doing what an operator would do for us. So we have a layer of safety built into the system itself that talks between the right-of-way and the trains, that makes sure that a train doesn't go beyond its approved speed limits and has proper separation from a train in front of it. That's in normal driver operations. When you're dealing with driverless, you're now taking over the controls of the operator, opening and closing the doors, setting the speeds, moving the trains, starting and stopping the trains. So it's another extra layer of controls, and for me what that means is an additional layer of testing and commissioning to make sure that we deploy a safe system.
Excellent. You know, we do get a lot of questions being driverless, and of course the reference point here in Honolulu is the bus, and every bus has a driver.
Right.
And so people often ask, what if something happens on a train? What if somebody has a heart attack or some other medical condition that needs, what if there's some sort of criminal behavior on a train and there's no driver to respond to it as a bus driver might on a bus? So can you help address that? Because we get that question quite a bit, actually.
That's a good question. So the trains themselves and the stations have CCTV cameras. So that's a first layer of ability to view and see what's going on within our system.
We have a large number of those.
Thousands of cameras, yes.
Okay.
And so we're within the trains. That gives us the visibility to see every point and position within the train that a passenger could be standing. In addition to that, we've got call stations within the train. So throughout the train, there's emergency call buttons that allows a passenger to communicate with the control center and talk to an operator that can either make the decision to stop the train right there, highly unlikely. Most likely in a situation where we have a medical emergency, we're going to take the train to the very next station and we'll call for medical emergency or medical support to meet at that station so that we have the best ability to serve that person's needs.
Right. And no two stations are really all that far apart.
No, the farthest station is about a mile apart, so time-wise not very far at all.
Right.
Yep.
That's an important consideration.
Yep.
Well, I know you brought along some pictures to share with our audience today, and I'd like to start and have us look through some of those if we can.
So this is a assembled car shell that we've produced out of Italy.
Okay, and so that's early on,
yeah. So what you're seeing right here is a paint. This is a car shell that's been completed in its assembly process. It's got fully welded aluminum car shell. It's been painted. Insulation has been installed on the insides. Flooring has been installed, and it's been shipped to final assembly. So we're kind of seeing this car shell here is actually being received at the final assembly facility. Here's a snapshot of what we call final assembly. It's really where all the wires and equipment are installed onto the train.
And where is this location?
This is located in Pittsburgh, California. It's just outside of San Francisco.
Okay.
As you can see, we're starting to pull in our miles of cable that we install onto the car itself.
And what do all these wires do? And so, I mean, what are they connected to inside that train car?
Well, inside the train car, we've got probably 15 subsystems: doors,
wow,
air conditioning units, event recorders, communications equipment, signs, CCTV cameras, and the like, and then a control system within the train that allows us to monitor the health of the equipment on the train. So all those cables are connecting lights, for example, and all the rest of the equipment within this train.
Okay.
So more cabling for underfloor equipment. We've got equipment that's installed inside the train, underfloor, and on the roof. Once we get all the cabling pulled, then we start moving into installing the heavy equipment, the boxes, and then we'll start putting the interior liners, the panels and walls inside the train.
Uh-huh.
And then it'll go, this is a snapshot of a train that's going into test. So once we get it fully assembled, we need to start testing all of first the cabling, make sure it's been installed properly, and then testing the functionality of each of the various subsystems. This is a key component, the truck frames. This is the wheels that allow the train to move. They come into this facility as a bare frame, and they're assembled here. This is a fully assembled truck that you're seeing.
Okay.
There you go, final picture of a truck that's getting ready to be put onto the train.
Right, so that sits under the train and allows it to move.
Yeah, throughout our system.
Okay.
So here I brought some photos of the wheel manufacturing process. About a year ago, I had made a visit to the wheel supplier to make sure that they were on schedule with delivery of wheels for our assembly of our first train. And this process takes a piece of bare metal, forges it, puts it through the forging process, stamps out a wheel, moves it over fully automated to a machining process, and then this is the final step where we're finally assembling the wheel itself. This wheel will get pressed onto an axle and then installed on that truck that we saw previously.
And where are the wheels manufactured?
They're coming out of Spain.
Uh-huh, okay. We have quite the international train car, yes?
Yes, almost all train cars are dealing with suppliers all over the world, throughout the U.S. and the world.
Uh-huh.
Here's a truck frame, and we've got some pictures of the various welding processes that lead up to a fully assembled frame. This is half-inch thick steel. It's very robust, intended to be so to allow the truck to last basically a 30-year life.
Uh-huh.
And so we're taking pieces and parts and welding them together into the final frame that I think you'll see right here. We're doing this is actually a weight test everything that we're putting on this train, we're actually weighing. It's got we're shooting for a weight for the vehicle itself, and each one of the subcomponents kind of feed up into that.
Interesting, yeah. Okay.
The important thing on weight is the heavier the weight, the more power it takes to move the train throughout the system. So
I see.
You set a weight for your train, and I'm happy to say we're actually meeting that intended weight. Here's some more just photos of the truck frame assembly as it's in process.
And that's still in Spain?
This truck frame is in Italy.
Okay.
Yeah. Okay, so now we're back to Italy, when the very beginning of the process. This is the car shell assembly that is done in Reggio Calabria, Italy. What you're looking at is a roof panel. Here we've got a couple of shots of underfloor and roof sections. I think the next one will be a roof section, which we're prepping for a fire test. So the roof and the floor have to, at a minimum, withstand 15 minutes of a constant fire flame burning on the car. And so we take it to a national laboratory and put it through this formal test procedure, and they literally take a cross section of the car shell to do the test.
Wow.
Yeah.
So that should give people another sense of their train car being a safe vehicle.
Yes.
Because it does undergo a lot of rigorous testing.
Quite a bit of testing at every level,
yes.
From the subsystems to the car shell, truck frames, all the way to the automated functionality testing. We're testing out, improving every piece and part that goes on the train.
That's very reassuring.
Yeah. What we're looking at here is a signal house, signaling equipment. So this is the brains of the operation that actually talks to the trains via the rail system. I wanted to show some reels of cable because the core systems doesn't function without the miles of control line cable, fiber cable that we install, and medium voltage power cable that gets installed to communicate and feed the system.
Look at all that, yes. So those pictures we saw were at the Rail Operations Center,
yes.
Right? So that facility, in addition to the miles of guideway and track, also have all that much kind of cable equipment?
Yes. So we've got an automated yard at the maintenance facility. It's got its own traction power substation, and it's basically everything that goes out into our rail line needs to be also at the maintenance facility to allow movement of the trains. This photo here, we've got some. I just came back from what I call a combined propulsion and brake test. We take all of the propulsion and brake equipment, the traction inverter that converts the DC voltage into AC voltage to drive the trains, the traction motors, the high-speed circuit breakers, and all the components that go from control to monitoring and diagnostic of the propulsion system. And we run it through a series of tests to prove out the functionality and the communications between the controls and the actual motors. And so here's the kind of front-end controls. And this console is actually gives us a view of the maintenance leg diagnostic system that it's installed on the train.
Wow.
So
everything's so high-tech these days, yeah?
Yeah.
Yes. Okay.
This is a traction power substation. So this is where we take our AC power, convert it to 750 volts DC, and we allow for the switching and feeding of power out into our rail system.
How many substations like that are involved with the entire system?
We have 14 substations throughout the system.
Strategically placed to?
They're about one every mile and a half, roughly. And yes, they are strategically placed to allow for contingency operations, where actually it's designed so that we have enough power to feed even full maximum operations at the 2030 ridership calculations and service headways.
Wow,
so
yeah.
This is a look at some of the communications equipment that we'll be having installed in our control center. As I mentioned the CCTV cameras. This is one of the CCTV camera consoles.
Right. Where
an
we'll
operator
monitor
can,
that kind of, yeah.
yeah, we'll be able to call up monitors onto the overhead screen and watch select monitors throughout the system. Communications is driven by servers and switches and all of the controls that go to talk to all of these various systems. And just to end supply, what you're seeing here is a sign that'll go out at a station platform, and it'll tell
Right.
basic passenger information.
There's a look at our first 4 train cars out at the Rail Operations Center in Waipahu.
Yep.
And that day back at in early May when we showed them off for the first time.
And this is what you'll see when we start service.
Where did all those wires go?
That's right, tucked behind all those nice panels and
Yes.
seats. So,
Very, very nice. Can you describe basically the dimensions of the train car itself?
so the train car, as you might have heard, it's a 4-car train.
Right.
Each individual car is about 65 feet in length. The full train is about 250 feet
Right.
long. A traditional light rail vehicle is like 100 feet, 95 feet long. So if you're standing inside this car and you look down to the other end of the train, 250 feet just seems massive.
Yes, it does.
And the neat thing about this train is the gangways, the passageway between one car and the next, is almost the width of the train itself. And that's highly unusual. Normally there's equipment lockers that kind of encroach on that gangway, and it's only about 30, 35 inches wide
Right.
on a light rail vehicle, which makes the car feel a lot smaller. So in our train, it's got a lot of room for people to move around and feel comfortable inside the train.
And even in systems with cars maybe nearly as large as ours, there's oftentimes doors between the 2 cars, right?
Yeah, yeah. So take, for example, the BART system. You
Yeah.
have to go through doors and walk through a gangway and open another door to get to the next car.
Right.
And this just kind of removes all of that
Yes.
and gives us that great big open feel that I think we all will enjoy.
Yes.
Yeah.
How many passengers comfortably can ride on one 4-car train, and how many can you just like squeeze in there? Because a lot of people, especially from here, have been to systems in Japan where they often describe people getting crowded into a train car. So give us some idea of
Right.
numbers, passenger-wise.
Unfortunately, I didn't bring my cheat sheet with me, but so for example, I believe we have around 70 seats on the train. So comfortably, 150 people could be on the train, and we're talking about 200 people, I think, on a train. It's either a car or a train.
Right,
I'm
right.
Sorry.
No, that's okay. I've seen that there's about 200 seats in a 4-car train, and probably room for another 100 people or so to stand comfortably, so you could move 600, 700 people per train, maybe 800 if everybody.
Yeah. I think I'm talking numbers for a single car.
Okay,
so
all right. Yeah, no problem.
Anyways, I don't have that in my head today.
Okay.
Thanks.
So tell us the arrangement now with Ansaldo and Hitachi and that kind of thing, because our contract to build the cars and operate the system is with a local joint venture, right? Ansaldo Honolulu joint venture. But Ansaldo recently was purchased by Hitachi from Japan. Can you tell us how
Sure.
that happened?
So originally the joint venture was between Ansaldo STS, it's a primarily US-based company, and Ansaldo Breda, Italy.
Right.
So STS provided the bulk of the signaling, communications, traction power, and Ansaldo Breda provided the trains. With the sale of Ansaldo Breda to Hitachi and portions of Ansaldo STS, it's primarily what we've seen as a name change. So Hitachi Rail Global created a subsidiary company called Hitachi Rail Italy. The management of the Ansaldo Breda company is the existing management of the Hitachi Rail Italy company. So from our contractual perspective, we're not seeing any change in our team that's providing the services to us. Our project management, our lead engineers, our testing and commissioning folks are all the same people that we've been working with all along.
Right.
What's really interesting is we're starting to see an uptick in business in all of the Hitachi Rail Italy facilities.
Ah.
So what Hitachi is doing, it appears to be doing, is beefing up work and really kind of embracing the Insalda Breda organization and kind of bringing it into the Hitachi Rail Global organization. So
and
I'm
that's
very
to our
happy.
Benefit. Yes.
It is, yes. Because the alternative could have been that they could have pieced and parted and cut the company up, and where we would have lost our knowledge base, right?
Right.
So here we're seeing that they're maintaining their power systems, they're maintaining their engineering teams, they're putting more work into production. So that's going to keep our support system that we want to be there after we open and on into the years into the future intact.
Right.
So that's good for us.
So right now we have 4 train cars or 1 train on island. And where are we in the manufacturing process? What can we foresee in the next year or so as far as train cars coming to Hawaii?
Right. So this summer we're starting testing of that first train car at the maintenance facility and it probably won't move out of the maintenance facility before the end of the year.
What kind of testing?
Initially what we're doing is same thing that you saw at final assembly. We're doing wire continuity testing, high pot testing. These are checking the wiring of the train. Then we move into what we call static testing, where we're going to start testing each of the basic functionality of each of the subsystems without moving the train.
I see.
And then we move into dynamic testing, where we start slowly moving the train, and we need to get up onto the guideway to really check the propulsion and braking and confirm the relationship between the 2 subsystems, and that we get the acceleration rates that we're looking for and the braking rates that we're looking for.
And when will we see that?
That'll be mid next year.
Okay.
You're going to see that.
Cool.
Yeah.
Yeah.
So that's train 1. Train 2, it's basically just about finished its assembly process. It's being tested. It's already entered into testing this last month in Pittsburgh at the final assembly facility.
Right.
Once the initial testing is completed there, it'll ship to us somewhere around the end of the year. So around the end of the year, we'll have 2 trains here on island. Train 3 is already in the assembly process, and that'll come early next year.
Right.
Okay. And then train 4, we're starting to see train 4 car shells show up at a final assembly right now to kind of feed into the process. What we're seeing is about 2 trains in final assembly at one time.
At any one time.
1 train in testing, and then it kind of just moves. It's a circular flow.
And we'll have a total fleet of 20 trains when
20
it's all
trains.
said and done.
Yep.
Right. And then how about when the Rail Operations Center opens and we have most of the trains delivered on island and we're actually providing service, rail transit service to our people here, who's going to be working at that Rail Operations Center, and how many people? Give us some idea of what things are going to look like 10 years out.
I was just looking at passenger or numbers for maintenance folks. So Insalda Honolulu joint venture has the contract with HART to provide the first 5 years of maintenance from full opening. So they are also providing the maintenance for the interim opening period if we choose to open the line from East Kapolei to Aloha Stadium.
Right.
Those numbers are a bit smaller, so I'll speak to the full opening, which is about 170 maintenance and operations staff. And you're going to see them split between operations folks that work in the control center and control the movement of the trains. You'll have vehicle maintenance folks that'll focus specifically on maintaining the electrical and mechanical systems on the train. And then you'll have what we call wayside maintainers, which will either be doing 1 of 3 different disciplines: signaling maintenance, traction power maintenance, or communications.
Right.
And then we've got the track and facilities that need to get maintained. of janitorial services.
Right.
So there'll be folks out maintaining cleanliness of the system.
And the
each-
stations.
Yep, and
Oh,
the stations for
all
sure.
right.
Yeah,
Look forward to that day.
yeah.
Yes.
Very excited.
We're out of time for today, though, Justin.
All right.
Thanks so much for joining us.
Thank you for having me.
Okay. And on behalf of all of the project team, mahalo for joining us today. And we'll see you again next time for another edition of Honolulu on the Move.
If you have a question you'd like us to answer on our next Honolulu on the Move show, go ahead and hit us up on Twitter or Facebook. Just two of the places where you can stay informed with up-to-date information on the Honolulu Rail Transit Project. And you can view our latest project videos on our YouTube channel. If you'd like more information on the project, or would like a presentation to your group or organization, give us a call at our project hotline at 566-2299 or contact us via our website at honolulutransit.org. You'll be able to keep up with the latest news and information about the project, important meeting dates, times, and locations, and examine the official documents that are guiding the project's planning and construction. Take some time to visit honolulutransit.org.